They are separated by a distance of 0.06 meter. The effective resistance we know is R1 plus R2. R1 equals R2, which is equal to R by convex. Compute the longest wavelength and series limit. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my today's session, I will be solving numericals from the model question paper 3. Hope you have practiced, analyzed the numericals worked out in the previous 2 papers. The first problem, students. The problem says 2 point charges 1 into 10 power minus 8 coulomb and 4 into 10 power minus 8 coulomb are 0.06 meter apart in air. They are separated by a distance of 0.06 meter. Find the location of the point between them at which resultant electric field is 0. I have worked out such problems in the previous sessions, alva? Now the problem says, so I consider this point as A and this point as B. At A, I have a charge Q1 and at B, I have a charge Q2. The magnitude of the charge at A is 1 into 10 power minus 8 coulomb. And the magnitude of the charge at B is 4 into 10 power minus 8 coulomb. So Q1 has a magnitude 1 into 10 power minus 8. Q2 has a magnitude 4 into 10 power minus 8. And they are separated by a distance of 0.06 meter. I have to find the position between them where resultant electric field is 0. So I assume P is a point between the 2 charges where the resultant electric field is 0. Now, the distance between A to P I call as X. So distance from P to B is what? So this is 0.06 minus x, and this x is what we are evaluating. And what is placed at P? UPC, test charge, which is testing the electric field. So UPC. So now recall, how is that we have done the problem? First, I will find the intensity at P due to the charge at A. I call that E1, which is 1 by 4 pi epsilon naught Q1 by R square. Expression for intensity, charge by distance square, or E1 is 9 into 10 power 9. Charge is 1 into 10 power minus 8. The distance is x square. Or this is E1. This is 9 into 10 power 1 x square. And I have to give the direction away from the UPC. So this is the direction of E1. Similarly, electric field, electric intensity at P due to the charge at B, E2 is 1 by 4 pi epsilon naught Q2 by R square. Or on substitution, E2 is 10 power 9. Q2 is 4 into 10 power minus 8. 0.06 minus x whole square. Or this is 36 into 10 power 1 divided by 0.06 minus x whole square. So this is the value of E2. What is the direction of E2 now? E2 should act again from the opposite to UPC. Now if you observe, E1 and E2 are acting in opposite directions. So what is the resultant electric field? So E1 minus E2 is 0. Why? They are acting in opposite directions. Or E1 equals E2. On simplification, which is your task, x turns out to be 0.02 meters. So this is the distance where the electric intensity is 0. The next problem, again very much done in my previous session. When two resistors are connected in series with a cell of EMF 1 volt and negligible internal resistance, a current of 2 by 5 ampere flows in the circuit. Two resistors are connected in series. when they are connected in series with a cell of EMF 1 volt, the current flowing is 2 by 5 ampere. So when two resistors are connected in series, so when the resistors are connected in series, the effective resistance we know is R1 plus R2. Now, we also know that resistance is V by I, which is R1 plus R2. What is the EMF of the cell given to be? 1 volt. So the EMF of the cell, we'll just change it, make it 2 volts. So this is 2 divided by, when they are connected in series, how much is the current flowing? This is 2 by 5, which is equal to R1 plus R2, or very clearly, R1 plus R2 is equal to 5. So I have got the value of R1 plus R2. When the same resistors are connected in parallel, the main current is 5 by 3 amps. I have to calculate the individual resistances. So, when they are connected in parallel, RP equals R1 R2 divided by R1 plus R2. V by I is R1 R2 divided by R1 plus R2. Now, how much is the current when they are connected in parallel? 5 by 3 ampere. So, again this is 2, 5 by 3, R1 R2 divided by R1 plus R2, which is 5, or R1 R2 is equal to 6. So I have got R1 plus R2. I have R1 R2. Now I use the equation of biquadratics. So R1 minus R2 whole square is R1 plus R2 whole square minus 4 R1 R2, which is called the equation of biquadratics. So this is 5 square, or this is 25 minus 24, which is equal to 1. Now I have the value of R1 plus R2, which is 5. R1 minus R2, which is 1. Two simultaneous equations. Solve them. You get R1 is equal to 3 ohms and R2 is equal to 2 ohms. So, on simplifying the simultaneous equations, we get the value of R1 and R2. This is simple. Just know the relations. This is a complete assignment for y'all. This is from the chapter EMI. Umpty number of problems I have worked out in this case. I expect y'all to find it out. Next one. A biconvex lens has a refractive index 1.5 and has focal length 10 meter. Calculate the radius of curvature. Very simple. Optics, Lensmaker's formula. What did Lensmaker's formula say? 1 by f is n minus 1, 1 by r1 plus 1 by r2. So what is that I have to calculate? Radius of curvature. Since it is a biconvex lens, R1 equals R2, which is equal to R, biconvex. So this is 1 by 10, which is 1.5 minus 1, which is 2 by R. 1 by 10 is 0.5, 2 by R, and on simplification, R is 0.1 meter. Now, I will have to find the focal length, which is given. The nature and position of the image. So use the lens formula. 1 by u plus 1 by v is 1 by f. 1 by 0.01 plus 1 by v is 1 by 0.1. So simplifying for v, so 1 by v is minus 90, or v is minus 0.01 meter, which means very clearly the image formed is virtual. Just use Lensmaker's formula, use the mirror formula, arrive at the result, which we have done almost always. First member of Balmer series of hydrogen atom has wavelength 6563 angstrom. Compute the longest wavelength and series limit. I will just give you the concept. I have done this earlier. So, longest wavelength is the wavelength of the first line. Since it is Balmer series, N1 is 2. Now N2 is 3, which is the wavelength of the first line. Use the relation 1 by lambda R N1 square N2 square lambda. Assignment for you all to finish the simplification. Series limit, wavelength of the last line of the given series, where N1 is still 2, N2 is infinity. Again use the same relation. We will arrive at the answers. So again, see students, any model question paper is dealing with the same concepts we have studied. My next class, I'll turn up with few more problems. Until then, have a nice time. Thank you.